Hydrochloric acid plus sodium hydroxide, titration exercise. The problem goes, during a titration, the following data were collected. A 50 ml portion of hydrochloric acid solution was titrated with a 0.5 molar sodium hydroxide solution, and 200 ml of the base was required to neutralize the sample. The question is, how many grams of hydrochloric acid are present in 500 ml of this acid solution? This is a titration exercise. Let us first understand how a titration is done. This is usually carried out to determine the concentration of an unknown, in this case, hydrochloric acid, by adding a small portion at a time of a known material, in this case, the sodium hydroxide. The sodium hydroxide here has a known molar concentration until an endpoint is reached. In acid-base titration, an indicator such as phenolphthalein changes color at the endpoint and titration is stopped. Okay, so this is before the endpoint. This is the desired endpoint where you have a very, very pale pink color of the phenolphthalein. This one is already overrun, meaning you have added too much of the titrant, meaning nalagpasan yung endpoint. Then, the volume reading is obtained. Dito, i-obtain natin yung volume reading so that we have here 200 ml. Again, yung known natin is the sodium hydroxide. This is the titrant. Molar concentration, 0.500 molar. Known volume. Okay, so it's like this HCl sample is obtained from this material. At yung natira, kumuha lang ng 50 ml at yung natira is 500 ml. Now, going back to the problem, ang problem kasi is to determine how many grams of HCl are present in the 500 ml of the acid solution. So, again, merong 500 ml na natira, kinuhanan lang to ng 50 ml para i-titrate. Okay, so ang natira dito is 500 ml. Okay, so we need to review stoichiometry. Okay, so in this type of problem, we need to establish the balance equation. Okay, this is very important. Then, we have the mole-mole relationship between HCl and sodium hydroxide. So from the balance equation, we can see very clearly that 1 mole of HCl will require 1 mole of sodium hydroxide to be neutralized. Iba naman yung sa mass relationship. So kung 1 mole ng HCl, ang mass niyan is 36.458 grams. This is the molecular weight. And also, for sodium hydroxide, ang 1 mole is 39.997 grams or roughly 40 grams per mole. Okay, so mole-mole relationship, 1:1. This is mass-mass relationship or gram and gram relationship. Now, reviewing our molarity formula where you have mole per liter solution, if we rearrange it a little bit so that we will have mole is equal to molarity times volume in liter. In other words, if I multiply together molarity and volume per volume in liter, I will get mole. Now, if I multiply molarity times volume in milliliter, I will get millimole. Okay, so this is the relationship. If I multiply molarity and volume of HCl, I will get millimole of HCl that reacted. If I multiply molarity times volume of the base, I will get millimole of the base that reacted. Now, since yung base ang known, 0.5 molar, 200 ml, at doon sa HCl, hindi natin alam. Pero alam natin that ang reaction relationship nila is 1:1. So that the amount of base that reacted in terms of mole will also be equal to the amount of acid that reacted. Kasi 1:1 relationship sa kanilang reaction. Okay, so ito, molarity times volume, I will get millimole of base. Molarity times volume, I will get millimole of acid. Okay, ito, known din yung volume ng acid. What is unknown is molarity. Okay, so doing my mathematics, I will have here 2 molar or 2m. This is the molarity of the HCl. Now, going back to the 500 ml. Okay, so there is a 500 ml solution that remained in the flask. Molarity is known from the earlier computation. It's 2 molar. The next thing to tackle is to determine how many grams of HCl are present in 500 ml solution. Okay, now we have to recall again that mole is equal to molarity times volume in liter. Now, mass is mole times molecular weight. So if I want to get the mass of HCl in that 500 and in this 500 ml solution, so I will multiply molarity kasi alam na natin yung molarity kanina, volume in liter, and molecular weight, which is 36.458. Now you will see 2 mole per liter times 0.5. This will become 1. 2 times 0.5, 1 times this will be 36. Will give you 36.458. Okay. Tingnan natin. If our computation is correct, tama din yung ating unit. Remember, we are trying to determine mass in gram. How many grams? Kasi yung problem natin, how many grams? Okay, so if our computation is correct, we will end up with gram unit in our final result. Tingnan natin. Yung mole na to will cancel out kasi ito nasa numerator, will cancel out with the mole here in the denominator. The liter here in numerator will cancel out with liter here in the denominator. So ano ang natira? Na-cancel out na yung mole, na-cancel out na yung liter. Ang natira is gram. So yan yung hinahanap natin. Gram. So, okay, yan ba yung hinahanap natin? We are asked for how many grams. Okay, so our final answer is in gram unit.